Greetings! During the past few months, we covered various aspects of application deployment. We strengthened code quality by running automated tests. We improved scalability by integrating external clusters and adopted configuration as code methodology with GitOps approach. Now it is time to cover another advanced configuration. This time it relates to security. In this video, we will demonstrate how to securely manage your sensitive configuration data stored in secrets by using an external secret store within a dedicated namespace by using the external secrets operator. Instead of hard coding sensitive data directly into secrets in the same namespace, we can store our tokens, credentials, keys, and other sensitive information in a remote secure location, and then synchronize this data with our application secrets. Think of it as a safe deposit box in the bank. You have a trusted representative, let's say your accountant, with the key to the safe. The safe contains your passport. A copy of the passport is required for most of your legal processes. Every hour, when a new legal operation is scheduled, the accountant takes the key, opens your safe, retrieves the passport, makes a copy, and returns the original. The copy is then delivered to your office where you need it. In this analogy, the bank is the Kubernetes cluster. The hourly schedule is the refresh interval. The accountant is the external secrets operator with the service account. The original passport in the safe is the external secret. The copy of the passport is the secret in the application namespace. And the bank vault is the secure namespace. In this demo, we will create a separate namespace in the cluster and store a secret containing database credentials there. Then, we will create a role with read-only permissions for this namespace and a role binding to grant these permissions to a specific service account. And lastly, we'll modify the application's Helm chart by adding templates for service account, secret store, external secret, and updated deployment with environment variables sourced from the synchronized secret. This architecture provides enhanced security with the following advantages. Sensitive data is stored in secure location, eliminating duplication and simplifying secret management across multiple applications. Access to the vault namespace is tightly controlled through role-based access control. Even if someone gains unauthorized access to the cluster, they cannot access secrets in the vault namespace without the specific service account permissions. Since this namespace is managed exclusively by the DevOps or security team, the attack surface is significantly reduced. Even if service account is compromised, an attacker cannot modify, delete, or create secrets. They can only read them, limiting the impact from any single point of compromise. In this guide, we don't install the external secrets operator on the cluster, but it can be easily done by running two simple commands. We will attach the instructions to the description of this video. So we start with the KubeRocketCI portal. According to the instructions, we need to create an application with GitHub as a Git server. Then, we need to create a deployment flow with the SIT environment. We skip these steps in the video as we did it many times in the previous guides and to save your time. To start from, let's create a vault namespace and a service account in the terminal. Our cluster uses Capsule for multi-tenancy management. This is why I need to add this label. You don't need it if you don't use Capsule. In this case, the kubectl create namespace command will be more than enough. Now, let's create a role that will be bound to the operator. The scope of the role should be limited to the namespace that stores the sensitive data. This role won't have rights to edit data it reads. Now let's continue by creating a role binding. Please note that this resource is created in namespace with a special pattern. EDP Delivery OS Dev is the namespace where the platform is deployed in. It's just like the demo namespace mentioned in the guide. Deploy is the name of the deployment flow you created, and SIT is the name of the environment within that deployment flow. Now, let's create a secret with sensitive data that will be accessed only by an ESO. Okay, great. So to continue, navigate back to the portal and head to the created application. Open the application Git repo. Clone the application, as we will need it to adjust its configuration to use the new secret. We cloned the application beforehand, so we will immediately switch to the IDE. We already created a branch and a number of external secrets templates in the application. So the first file is the service account that will use the role we created earlier. Its scope is the SIT environment of the deployment flow. The second resource is secret store. It tells external secrets operator where and how to connect to the backend that hosts the secrets. Here we use the Kubernetes provider. ESO will read secrets from the remote namespace, ETP delivery OS dev vault, using the service account, secret manager, and cluster CA. So the secret store is essentially the connection configuration. It's like a bridge between ESO and the actual secret store. Thirdly, we create the external secret resource. This file defines an external secret named Mongo. It describes what to sync, which remote secret to use, and how to map it onto a Kubernetes secret. It references our secret store demo and says, take the remote secret Mongo, read its username and password fields, and create and update a standard Kubernetes secret named Mongo in this namespace. And regarding the deployment, we define two variables, Mongo username and Mongo password. Now it is time to create a pull request for the application. Let's make a commit. Now let's push it to the origin. Create a pull request. This change integrates application with external secrets operator. Once the pull request is created, it will trigger the review pipeline. We can navigate back to the portal, select Pipeline Runs, and view its details. We will fast forward this process in the video. By the way, if you use an application template and your review pipeline fails on the Sonar step, you can try adding a couple of files to the Sonar Kube exclusions. Now that the review pipeline is complete, we can safely merge the pull request. Once the pull request is merged, the build pipeline starts automatically to create an application image. Great! Now we can deploy our application. Let's head to the deployment flow. Select Environment and click Configure Deploy. Select the latest version and click Start Deploy. In the Pipelines tab, we can view its details. Marvelous! We can now verify that the secret was created by the ESO. Navigate to the terminal and get the secret store resource. The secret store was successfully created. Now let's check our secret. Here it is. The external secrets operator eventually creates a Kubernetes secret in the application namespace, so let's check it too. The secret was successfully created. Please note that it has both the external secrets created by and external secrets managed labels attached automatically. It proves that it was actually created by the external secrets operator. Argo CD application resource also proves that everything was created successfully. We set up a vault namespace with credentials and role-based access control, so only ESO's service account can read them, and added secret store, external secret, and deployment changes to the app. The app now gets Mongo credentials from the vault via ESO, not from Git or the app namespace. ESO keeps sensitive data out of Git and application namespaces. You store it in one secure place and ESO syncs it into Kubernetes secrets. That gives one source of truth, read-only access for the operator, and no secrets in the repo. In the next video, we will integrate ESO with AWS Parameter Store. That's it for today. Thank you for watching.